Hello, everybody. Today we're going to do a review of section 6.3 that was covered in the video yesterday. This is the section where we start to learn how do we figure out the three-dimensional shape of molecular structures. So our learning objectives, we're going to learn to predict the shape of a molecule using this VSEPR theory, valence shell, electron pair, repulsion theory. And then we're going to associate the polarity of these molecules with the shapes of the molecules. Based on the shapes and the atoms that are inside the molecules, we'll be able to determine the polarity. And using this information on polarity, we'll be able to predict the properties of these substances. So let's go to the end. So go ahead and make sure you watch this video that was done yesterday. Okay, here are the key understanding, the key ideas that you need to learn. Number one, in VSEPR theory, valence shell electron pair repulsion theory, what information about the central atom do you need in order to predict the shape of the molecule? Well, you need to know where are the electrons hanging out around the central atom. And there are several ways that these electrons can present themselves. Number one, they can be a single pair of electrons, and we call that a lone pair. They can be a lone pair of electrons, which is just two dots. They can be a single bond. Which is a long dash, and that represents two electrons. It can be a double bond, and that's represented by two parallel lines, and of course that equals 4 electrons. For 2 electron pairs, 4 electrons, or they can be a triple bond. And that's three dashes, and that of course equals 1, 2, 3, 4, 5, 6 electrons. What is the only shape that a molecule made up of 2 atoms can have? And that is linear. If you have a compound like carbon monoxide, there's only two atoms in the molecule. So just from your geometry class, you know that it has to be a linear structure. So this is the CO molecule drawn in a Lewis structure. Explain how the Lewis structures help predict the shapes of molecules. Well, depending on the bond structure, on how many bonds, where the electrons hang out around the central atom, that will determine the structure, because these bonds and these lone pair electrons, they want to separate themselves as far as they can. So an example, you can see here, oh, I don't think that's the right one. There we go. You can see here that depending on how many, this is in the VSEPR table, you can see that depending on how many places where the electrons are found will determine the structure. And that depends on places that are bonding, places with bonding electrons, and places without bonding electrons. That will determine the three-dimensional structure. Okay, explain how a molecule that has polar bonds can be nonpolar. So the idea behind polar bonds is that one of the atoms in the molecular structure has a different electronegativity than another atom in the molecular structure. If that occurs, then you have unequal sharing of the bonding electrons. So an example of that we talked about is carbon dioxide. If you have carbon is attached to oxygen. Oh, I did that wrong, didn't I? Put that back. If you have an oxygen or carbon in the center and it's attached to two oxygens, carbon dioxide, you will notice that the oxygen has a higher electronegativity. So as a result, these bonding electrons in this pair of electrons is going to be pulled closer to the oxygens. And that's going to make the oxygens have a slightly negative charge, and the carbon in the center a slightly positive charge because the electrons are being pulled away. And that's going to cause a force going this way and going that way. But they're equal and opposite because the two ends have the same type of atom, two oxygens. So that's how you can have polarity inside a molecule, but the molecule is still nonpolar. Give one reason why water molecules are attracted to each other. Well, in water molecules, I'll do it over here. In water molecules, it turns out that the two oxygens are at the two hydrogens, I should say, the two hydrogens are at an angle when they're attached to the oxygens. They're at an angle. Because they're at an angle, they're not pulling opposite each other. And that gives the top of the oxygen side of the molecule a slightly negative charge and the hydrogen side a slightly positive charge. And because of that, it's like a little magnet. So this negative side of the oxygen can be attracted by the positive hydrogen side of another water molecule. And so on. And we can have another water molecule up here being attracted. And that is really this idea that water is sticky. Water attracts, water molecules attract each other. That's really the reason that there's life on Earth. Okay, so that goes over all of these questions at the end of the section. So I'm going to end the video right now. I hope everybody's doing well, and I'll talk to you later. Bye-bye.